Hello, I'm Salman from 2B24 from the group Yawns. I'll be doing section D of the project. There are 4 questions that I need to do for the project, which is firstly, what are the differences in the proof and the use of the two rules? Second, compare and contrast the advantages and disadvantages of the two rules. Thirdly, I will need to summarize the above in a table format. And fourthly, if there are any other methods for computing integration numerically. Now we will be going to the first question of the project. What are the differences in the proof and the use of the two rules? For the trapezoidal rule, the integrand is approximated to be a straight line within each sub-interval, while for the Simpson rule, integrand is approximated to be a quadratic within each sub-interval. Another difference is the number of strips n for the trapezoidal rule can be of any number, while the number of strips n for the Simpson's rule must be an even number. Next, we will comparing and we will compare and contrast the advantages and disadvantages of the two rules. For the advantage of the trapezoidal rule, there can be any number of data point, and the data point can be an arbitrarily, which is in a random manner. And the advantages for the Simpson's rule is that the error reduced proportionally to the square of the data spacing. So basically it means the smaller the data spacing, the smaller the error. Next, we will seeing the disadvantages of the two rules. For the trapezoidal rule, the disadvantage is that the error only reduces proportionally to the data spacing. And for the Simpson rule, there must be an odd number of data points, which is not the same as the number of strips. The data point, and secondly, the data points must be evenly spaced out. For the fourth question, are there any other methods for numerical integration? Ta-da! Here's the summarized version of it. Yes, there is. One of the other methods is the rectangle rule, but it is less accurate compared to the Simpson's rule and the trapezoidal rule, because for the rectangle rule, it uses the area of rectangle under the graph. Thus, there will be more error. And if we allow the interpolation point to vary, there will be another group of formulas, such as the Gaussian correlation. Typically, it is more accurate compared to the rectangle rule, the Simpson's rule, and the trapezoidal rule, which is called the Newton-Cotes formula. Thank you.